In this video, we're going to be using permutations and combinations to calculate probability. A permutation is an arrangement where order is important. For instance, it matters who is president and who is vice president. We have a formula to calculate the number of permutations, n pick r. So if we have n things, we start with n factorial, and then we divide by n minus r factorial, where r is the number of objects selected. So to use the formula for 8 pick 2, that would be 8 factorial over 8 minus 2 factorial. Writing this out the long way, eight minus 2 factorial equals 6 factorial. And now we notice that we can cancel some things, leaving us with 8 times 7. So 8 pick 2 equals 56. We could also get that on a calculator. Now, calculators do permutations in a variety of ways. Let's take a look at the Desmos calculator. Here we are on the main screen of the Desmos scientific calculator. And we don't see anything about permutations on this screen. And ABC, that's just a keyboard. But on the function screen, we notice n pick r down here in the bottom left corner. Now, different calculators do this differently. Sometimes you type in the n first, and then click the button, and then type in your r. But on this particular calculator, we hit the n pick r button, and then we type in our n, followed by a comma, followed by the r, and it tells us what 8 pick 2 equals. So that's one good option for calculating permutations, is to use a scientific calculator to get that number. Now also, just by looking at what's going on here with what canceled, this kind of canceling is going to happen every time with the permutation formula. So we notice here we ended up multiplying just two numbers. Well, that 2 was how many numbers we're picking. So we just start with the number of items, and we keep multiplying by the next smallest integer until we've picked all of our items. Let's do it that way on this example about the soccer players. A team of 18 soccer players needs a captain and a co-captain. Find the number of different ways of choosing a captain and a co-captain. Now, there's a difference between being a captain and a co-captain. So notice on this problem that order matters. So this is a problem for using permutations. All right, so we want 18 pick 2, because we're picking one person for the captain and another person for the co-captain. So we'll start with the 18 and keep multiplying by the next smallest integer until we've picked two people. So that would be 18 times 17. And on our calculator, we notice that there are 306 arrangements for choosing a captain and a co-captain from a group of 18 people. Before we get to probability, let's also review combinations. Now, combination is an arrangement where order is not important. For instance, the math club coach might need to select two members of the club to attend the math bowl. It doesn't matter who the coach chooses first or second, it just matters who gets to go. Now notice this formula for n choose r is almost the same as the formula for permutations. The only difference is that the combinations formula has this r factorial in the denominator also. Now that's because the combination is going to be smaller because we don't want to double count arrangements that contain the same things but are just in a different order. Because with combinations, the order is not important. So we don't want to double count arrangements containing the same items. So let's use the formula to calculate 10 choose 3. We'll start with 10 factorial in the numerator. And we're going to divide by 3 factorial to avoid double counting. and also 10 minus 3 factorial. So most of this is the same as the permutations calculation. We're just dividing by this extra piece. Well, let's write it out the long way. All right, once again, we notice a lot of this cancels. 9 and 3 are both divisible by 3, so that 3 cancels out, and this 9 can become a 3. 8's divisible by 2, which leaves us with 10 times 3 times 4. Well, 3 times 4 is 12, times 10 is 120, and there's nothing left in the denominator. So we end up with 120 combinations. Now, once again, we could do that on a calculator. On this calculator, we click the N choose R button, type in the N, a comma, and the R, and it tells us that 10 choose 3 equals 120. Looking at this a little closer, this whole calculation is really the same thing as 10 pick 3 divided by 3 factorial. So in other words, another way to calculate this would be to start with the 10, and then keep multiplying by the next smaller integer until you've picked 3 things. And then to avoid double counting, we'll divide by 3 times 2 times 1. All right, let's try that over here. So we have a group of 40 people who are going to run a race. The top 5 finishers advance to the finals. How many possible groups of winners are there? All right, so we're trying to calculate 40, choose 5, because in this case, order does not matter. All right, so we're going to start with 40 and keep multiplying by the next smaller integer until we've picked 5 numbers, and then we'll divide by 5 factorial. All right, so we could certainly go through this and simplify some things, but in this case, it certainly would be a lot easier to just use a calculator. So let's go over to our calculator and figure out what 40 choose 5 is. We get 658,008. So there are 658,008 possible groups of winners when we're choosing 5 racers out of 40. Let's find some probabilities using permutations and combinations. Now remember, to calculate a probability, we'll create a fraction, and the numerator will put what we want, and in the denominator we'll put the total. All right, a jar contains 5 black buttons and 2 brown buttons. If 5 buttons are picked at random, what is the probability that all of them are black? Now with probability, there's usually more than one way to do the calculation, but we're going to use permutations and combinations here. So first, we need to decide which one of these two it is. Well, here, order does not matter. So we're going to use a combination. We don't care what the order of the black buttons are, we just want them all to be black. So we notice here that there are 7 total buttons, because there's 5 black buttons and 2 brown buttons. And we are going to choose 5 of them, and we want all of them to be black. So this would be 7, choose 5. So to calculate this by hand, the quick way, we'll go ahead and calculate 7, pick 5, and divide that by 5 factorial. Because remember, the combination is the same as the permutation formula, but we have to divide by r factorial. All right, 7 pick 5. We'll start with 7 and keep counting down until we've written out 5 numbers. And notice we stopped at 3. We'll have to remember that. And we'll divide by 5 factorial. Notice this 2 times 1 does not appear in the numerator, so we've got 5 times 4 times 3, cancel out the other 5 times 4 times 3. 6 divided by 2 equals 3, so that 2 cancels out and the 6 becomes a 3. We don't care about that 1, leaving us with 7 times 3. So when we have 7 things and we choose 5, there are 21 different arrangements, not counting doubles, because we don't care about the order. So remember, this is a probability question. Now, one of these 21 arrangements would be all black. So the probability of choosing all black marbles would be 1 out of 21, because there's only one way to get all black out of 21 different arrangements. A quick note on the letter P. In math, we use a capital P quite frequently. Up here, we used it for the word permutation. Down here, I used it for the word probability. So this statement is just saying the probability of getting all black buttons equals 1 over 21. So be on the lookout for different uses of a capital P. On this one, there are 10 songs on your playlist. With random shuffle and no repetition, you listen to 2 songs. What is the probability that you listen to your favorite song first and your least favorite song second? So in this case, order is important. We'll use permutations because we don't need to worry about double counting because each different arrangement is unique and we want to include those. All right, so with permutations, we have, in this case, 10, pick 2. So we'll start with the number 10 and count down for 2 digits since we're picking 2. So we have 10 times 9. And we get 90 different arrangements. So there's 90 different ways to pick 2 songs from a group of 10 when order is important. This is a probability question. This P stood for the word permutation. This P stands for the word probability. So inside parentheses, I'll just kind of do some shorthand here. So we want to get the favorite song. So I'll do F for our favorite song. And then our least favorite. So let's say the worst song. So the probability of choosing our favorite song first and our worst song second equals 1 out of 90, because there's only one way to pick your favorite song first and your least favorite song second. And we have 90 different ways of picking 2 songs from a group of 10. You've purchased a lottery ticket, and your numbers are 2, 4, 3. A lottery official randomly selects 3 balls from a set of 6 balls that are numbered from number 1 to number 6. To win, your numbers must match the selected numbers in order. What is the probability of winning the lottery? All right, since the order matters here, we will once again be using permutations. All right, looking through the question here, there are 6 balls total, so it's going to be 6, pick 3. This will tell us the total number of ways to pick 3 things from a group of 6 where order is important. All right, doing it the short way by hand, we'll start with the number 6 and keep multiplying by the next smaller integer for 3 numbers. And 6 times 5 times 4, that equals 120. So there are 120 ways to pick 3 numbers from a group of 6 where order is important. Now, only one of those 120 ways will be 2, 4, 3. Now, this next capital P stands for the word probability. So the probability of getting 2 and then 4 and then 3 is 1 out of 120. So we have a 1 in 120 chance of winning that lottery. A small pond contains 6 catfish and 3 bluegill. If 6 fish are caught at random, what is the probability that all of them are catfish? Right, in this case, order does not matter. So we're going to use combinations. Right, in the pond, we have 9 fish. We're catching 6 of them, so we're choosing 6. So it'll be 9, choose 6. Instead of doing it the short way by hand, let's go ahead and do 9, choose 6 with a calculator. On this calculator, once again, I start by clicking the combinations button. Then I do 9, 6, and we get 84. So there are 84 ways to choose six things out of 9 where order is not important. Right, this is a probability question. So we're wondering, what is the probability that all the fish we catch are catfish? Well, there's only one way to get all catfish. So the probability of all catfish equals 1 out of 84. In this video, we use permutations and combinations to calculate probabilities. I hope these examples have been helpful. This is Mr. Ela, signing off.